Okay, so in the warm-up problem, a student shared their work, and they started by applying the product property, which says that if you have the sum of two logs, you can rewrite it as the log of their product. And then the student multiplied the x times each term here, and then rewrote it as an exponential. So remember that the base of the common log, if it doesn't say the base, that would be base 10. So then to rewrite it as an exponential, it's 10 to the 1 equals 2x squared plus x. So then you need to subtract the 10 to get one side to be 0, and then you need to factor. So the student found the numbers that multiply to negative 20 and add to 1. Those numbers were negative 4 and 5, and he replaced the x with negative 4x plus 5x. And then he factored the common factor out of the first two and out of the second two. And then he has the factors 2x plus 5, x minus 2. Set them both equal to 0, but then had to throw out negative 5/2 because when you plug that back in, you're taking the log of a negative, which is not allowed. So you just have x equals 2. This next strategy we actually went over already. To solve an exponential equation, you want to write each side as the power of a common base. So in problem 1, we wrote them both as powers of 5. 1 over 125 is the same as 5 to the negative 3. And then you take the exponents, 2x minus 1 and negative 3, and you set those equal to each other. And then you divide and you get x equals negative 1. It's okay to have a negative exponent. It's not a logarithm equation. In problem 2, you make them both powers of 4. So 1 over 16 is 4 to the negative 2, and 64 is 4 to the 3. Remember to distribute the 3 to the x and to the 5. So you have 3x plus 15. Solve your equation, and you have x equals negative 17 over 3.